We've been talking about the mole, and you should feel very confident with your basic conversions from atoms to moles, moles to grams, etc. Yesterday we got into percent composition, and we talked about percent by mass of each element in the compound, as well as determining the mass of an element in a sample of compound. And again, very solid there. The other piece we want to be able to do today and in the laboratory for percent comp is the percent of water in a hydrate. In the lab right now, you are cooking your hydrate. You are heating it so that you drive the water from the sample. You can figure out the percent of water in a hydrate both from the chemical formula, which we're going to do now, and experimentally in the lab, both of which you need to be able to do for your test. On your quiz, I'll just ask you to do it from the chemical formula. Next week, we'll get into determination of empirical and molecular formulas. Very straightforward, and I feel very confident that you'll be very strong with it. So to determine the percent of water in a hydrate, you follow the same steps as we did yesterday. You're going to write the chemical formula of the hydrate. You're going to determine the formula mass of the hydrate by adding the water molecules to the anhydrous material. I'll illustrate that for you. And then the percent of water in a hydrate is how many water molecules you have times the molecular mass of water. We determined the molecular mass of water in our previous lesson at 18.015 grams per mole. And then we will divide by the formula mass of the hydrate. Let's walk through this first problem together, and then we'll try one alone. And then we also can do it for the substance we're using in the lab, and you'll be able to compare these accepted values that you get from the chemical formula alone with your experimental data, and you can determine percent errors. So in this first one, we want to determine the percentage of water by mass to the nearest hundredth for magnesium perchlorate hexahydrate. Let's take a look. We have magnesium perchlorate hexa is 6 waters. First thing we have to do is get the formula mass, or the second thing once we write the chemical formula is get the formula mass of the hydrate. We have 1 magnesium, 2 chlorine, 8 O's. Be careful with the chlorate, perchlorate, chlorite family. It's chlorine in there, not C and I. It's a mistake I see very often. Be careful. You also have 6 water molecules. So the first thing we're going to do is get the formula mass of the hydrate. Again, 6 water molecules inside the crystal lattice structure of magnesium perchlorate. 1 times the molar mass two times the molar mass, eight times the molar mass of oxygen, and then 6 times the molecular mass of oxygen. I'm sorry, of water. If you don't know the molecular mass of water, you could figure it out 2 H's and 1 O. But if you know the molecular mass of water, you can save yourself a step right there. And this is 331.293 grams per mole. So the only difference here compared to what we did yesterday is you have to add the water molecules in. So that's the formula mass of the hydrate. To determine the percent of water then, you will take the 6 waters times the molecular mass of the water, and you will divide by the formula mass of the hydrate. And you will multiply that by 100. It asks for to the nearest 100, and that's 32.63% water in that hydrate. So grossly similar to what we did the other day. You figure out how many waters you have from the chemical formula. You multiply it by the molecular mass of water. You divide by the formula mass of the hydrate. That includes the water molecules. That's the common error. Be careful. Divide, multiply by 100. There's your percent water. Questions? Let's set the second one up and make sure you can do it. The second one says determine the percentage of water by mass to the nearest 100th in calcium sulfate dihydrate. So the first thing we need to do is write the chemical formula for calcium sulfate dihydrate. How do we write that? Calcium sulfate, di is 2, H2O for water. I want you to figure out the percent of water. You want to try?
Yeah.
Go for it.
shouldn't it be, shouldn't there be a 2 on the outside since calcium?
This is 2 plus and this is 2 minus, so the charges would have canceled. What'd you get? Percent of water, silly. That's what I got too. And I'll show you how I sort of did a little shortcut, which I think you'll like because I know you hate writing things out again and again and again. So when I set mine up, I did it just like that. And that would be full credit. Cute little shortcut. I just grabbed it right out of there. How'd we do? All right, so you can get the percent of water from the chemical formula. Now, one thing I want to make clear to you for the lab is this would be the accepted value. This would be the value in the literature. You are going to be getting experimental values in the lab because you are going to take a sample, you're going to heat it, and you're going to drive the water off. So you'll be left with an anhydrous sample, and from the masses you have before and after, you can calculate the mass of water that you have, divide it by the mass of the hydrate, and you will be able to determine the percent of water experimentally, and you'll compare it to an accepted value. In the lab, you are using copper 2 sulfate pentahydrate. So you can figure out the accepted percent of water in this hydrate, and then you'll compare it to what you get in the lab, and you'll see how good of a job you've done. And we will be working on that in the lab. So you want to be able to figure out the percent of water in a hydrate. And in terms of your quiz, I'm going to give you a very simple one, like one of the ones we just did. But you do want to be comfortable with the entire percent composition concept. And most of you had mastery of those concepts before you left yesterday. Questions on percent of water in a compound? Okay, so you're solid now with percent comp. You know how to do simple conversions. That's as far as your quiz goes. Your quiz is next week. Questions?